let's understand grep. Assume we have this rrr.c which has some content. Now I want to know all the lines where this word is used. So what I can say is grep for word in rrr.c. That means search this pattern word in rrr.c and it will show me that it's coming on 3 lines. There are different options. I can even say that, okay, show me the numbers also, line numbers also. It will tell me that these are the line numbers. We are just searching for some word in a file. Maybe I want to search for by, or maybe I want to search for the exit statement. One way to search is in the VI also. I can say search for print and I can keep pressing N, but that's in the editor. You can search in the command prompt also, and then you can combine multiple commands using pipe, that the output of one command is fed into the other command. So it becomes very powerful. You can also say that grep printf in all the files. So there is a special keyword star. Star means all the files. In Windows, we are used to write all files as star.star. In Unix, there is no compulsion that you must have a .c, .s or .txt. If you don't give, it doesn't bother. So normally you just say star, and star will include dot also if there is. If there is not, no problem. So just grep printf star. What it says is I cannot find in these directories. These are directories, and in rrr.c I have. If I copy rrr.c into some xyz.c, now I run the same command, search printf in star. You see that it searches in all files. So maybe I can say star.c because that will clean this output. So that is what grep does. Let's say you say printf, and if you don't give any file name, nature of most Linux commands is if you don't give a file name, they operate on standard input. And the standard input is what I type. So if I type A, B, C, D, E, F, G, H, printf is not there. And if I say printf hello, it matches. So if you don't give any arguments, it works on the standard input. Now this is exploited by our earlier command when we were searching for a process, ps minus ef, and then we were looking for a process. So I will look for a process called bash right now because a.out is not running. So what I said is ps minus ef pipe grep bash. That means I'm grepping bash on the output produced by the previous command. The output produced by the previous command is piped into this. When this pipe happens, the picture is like this. PS is one process and the standard out of PS, that means the output of PS, is actually connected with the standard input of grep. So literally it means a pipe of data. Whatever the first command produces as the output is fed into the second command as input. You can even extend this output is given to some more thing. For example, let's say you want to search for grep, but you also want that it should have some other keyword also. Maybe you do this filtering. I mean, filter the lines which are selecting that grep pattern, and then another filtering. It should match that also. I don't get anything with ABCD, but if I just reduce it, I get something. But I have applied now to filters. You can consider them filters also because you are getting a stream of lines. You filtered, selected some line by grep bash, then you selected some more lines selectively further by grep A. So this is how this ps minus f grep bash works.